Okay. So your test is tomorrow. Yes. Yes. On my website, under the documents page, I did put kind of a how to study. Nope, that's not it. Under the calendar, sorry. Where did I put it? I thought I did somewhere. No. Under more details, under Friday, more details, you should see something like a BC how to test prep as demonstrated on fall test 2, right? This is how I studied for math tests. It's what will work for this test. Basically, I just kind of walked you through how to study for the test. So this is like what I would do in a test review during the class. What did I teach? You'll need your notes out, your homework's out, and gradually go through it. The test is through 75. So when you go to 75, each time you basically, you say, what is there to study, or what do I need to memorize? What were the big ideas, the objectives in the notes? What kind of examples did he hit in the notes? What kind of problems were in the homework? And then you go on down to the next set, 74. So for example, continuity. Do you know the definition of continuity? Okay, if so, then you'd be good. But if not, I would print out a study sheet and write down a few things. You should know it. Same then goes to fluid force. I just basically go down each set, practicing, and if you look through, take the time to look through this, I feel like you will be prepared for the test. I did not print off copies for you. It is on my website under Friday's day in the calendar. Understood? It is optional. It is not required. If you feel like everything's been going great and you are locked in, then you might just be fine coming in cold. That's cool. If you feel like you need more practice on any topic, then please come in. Oops, that's not what I wanted. Come in, and I'll be happy to give you practice on AP1. Let me tell you a little bit about my tests and how they're structured. It is 2 pages. The first page is calculated. I will start you the minute you walk in. So if you come in, with 4 minutes left to spare in the passing period, you can start 4 minutes early as far as I'm concerned. I will say that over the course of the year, as people get to know me and how long my tests run, it's pretty common that when the bell rings, everybody has already started the test. People, I'll just say it this way, I'm terrible at doing, and the tests are often too long. So I often have BC people running to my class to start the test. I don't know I can't remember if this test is long or short, but if you're a slow worker, I get here fast, right? I will try and tone it down. I will try and get the length right, but I promise you nothing in terms of success. The first page is calculus. It's all calculus. Calculator. Excuse me. The rest is English. The first is calculator. The front is more like short answer, multiple choice, like you've seen in the pretty typical Saxon book problem kind of thing. It should take you roughly 10 minutes. The back is AAP free response question. Let's just go FR2 for short. That should take about 15 minutes. When you are done with the first page, if there's a problem you want to come back to, that's fine. You can keep the first page, but you just can't use your calculator. That's the way the AP test free response is done. Once you pick up the no calculator page, you can continue to have the calculator page in front of you. You just can't ever use your calculator page. So I would get to the point where I don't need my calculator anymore. And if there's a problem you want to go back to, then keep the first page if you want. And go back to it later. Just make sure you don't need the calculator to do so. If you're good with the first page and you want to turn it in, fine too. Pick up the second page, and page 2 is much the same. The front is short answer. and the back is AP free response. So it again should be roughly 10 minutes for the front, 15 minutes for the back, 15 minutes total. When I go to grade it, I usually grade both pages separately and put them in the grade book separately. I don't remember, I probably haven't remembered the syllabus at this point, but I don't do test drops quite like Miss Karen does. I think she takes your lowest test and replaces it with the final grade or something like that, or grade on the final rather. I don't do that. I take the lowest 2 pages of your test and just drop it. Let's just drop it like it doesn't exist. I do 2 pages separately because that's in your best interest. It's sometimes the case that on test 1 you killed page 1 but you bombed page 2. Well, then you could keep page 1 when you go to do test drops and dump page 2 and save another page drop for another test. All that drop stuff is for people with a homework average of 90% or better. I got to tell you, the way I grade homework, if you don't have a 90% homework average, you're doing something wrong, because I grade homework easy. You should have a homework average of 90% or better, or you better stop skipping problems and get your act together. All right? Homework is a gift. The whole way I structure my test grades are, and where I tend to draw the line, is based on you being a person that kills the homework. I fully expect your homework average to be 90, 95, 100%, so that my test can be harder. All right? If you are also doing terrible on the homework and the test, then you're going to have difficulty getting a grade that most of you want. All right. That's about it on the test. Any questions about what the test is? Cool. Okay. Make sure when you go to turn it in, that first of all, make sure your phones are never out at any point, even when you're done. Make sure that when you turn it in, if you go to the basket, you're turning it in, period. There's no, oh, you go to the basket, you somehow have an epiphany, but oh, now you need to write your name. No, if you're at the basket, you're turning it in, period. I don't care if your name's on it, it's too late, turn it in. Okay, there's no coming back to it after. Okay, sorry, that's good. Test is tomorrow. I will be here 7th hour, obviously. I'll be here 7th hour, obviously. I'll help you after school. I also will review before school if there's stuff you want to practice. Then I'll be happy to give you more practice on that. What's due? Today, 77 will be due. Tomorrow, 78. Today, 78, and on Wednesday is that fun sheet on 78. Is that what I called it? Fun sheet 78? Oh, I didn't call it. I called it AP practice. It's a fun sheet, really. Fun sheet. Yeah, exactly. Worksheet has such a negative connotation. All right. Okay, are we all good? Would you go to the back bottom? I guess this really wants to be seen. The back bottom, I would like you to put down a few notes. I'm talking of the blue sheet. These are note sheets at the back of the bottom. Would you just jot these at the back of the bottom of the note sheet you picked up? These are notes that didn't make the cut. I forgot to put them in before I made my copies, so I want to get these in first and foremost. All right? So, today we're going to talk a whole lot of movement. And you've done movement quite a bit. You've done linear movement. In Calc 1, you do linear movement, which is movement in one dimension, along a number line, or up and down, right? In Calc 2, you do rectilinear, which is linear motion in 2 dimensions. So it might be, rather than just doing this way or this way, doing this way. Okay, yeah, you could actually do that. And then Calc 3 is 3-dimensional movement, so it's this way. It's all the same ideas: velocity, acceleration, position, speed. It's just getting used to 1, 2, or 3 dimensions. Right? Now, that said, it is my expectation that given one of position, which I'll call P, some people call it S, it depends on the problem. velocity and acceleration, you should find the other two. You should be able to find the other two. Okay, so let's look at the three cases. If you are given position, how could you find velocity? Velocity by the derivative. I don't need to get all fancy table-like. Let's just say it. Find velocity by the derivative. Was the derivative of position. Okay? How could you find acceleration? Yeah. The second derivative of position or the first derivative of velocity. Would you agree that you would not need an initial condition? It wouldn't. All right. Now let's go if you're given velocity. How could you find acceleration? If you're given velocity, what's acceleration? Derivative. Acceleration is derivative of velocity. Yay? All right. A little harder would be to find position. So how would you find position given velocity? There we go. All right. So P is the integral of velocity. You could go two ways. You could either get a plus C and use the initial condition. When you get an anti-differentiate, is that C always the initial position? No, it is not. Please don't say that. It's not always true. Okay, so you could do an, let me say it this way, you could get an indefinite integral, find the plus C by using the initial, or you could do a definite integral. How could you get position as a definite integral? Position at time is make start plus change. Initial position plus change from 0 to t. Okay. Not dt, that would have to be du or d something else. You need a dummy variable, yeah? All right, are we cool? All right, last but not least, what if you are given acceleration? You would find velocity by integrating acceleration, and again, find the plus C or a definite integral. Not sure when there's a lag time here. And then how could you find position? Position by integrating velocity. And again, you can find the second constant or definite integral. Okay, now then, let's talk a problem that is pretty common. I dressed it up and gave it a lot of AP flavor. So, my goal is that you can show the relationships in an AP style with wording correctly between the three functions and also talk about speed. So would you get out a calculator, please, and put the velocity function in. And this will be calculator active examples. Doc B. I can't remember what the function is. T plus 1 sine t squared. Sine x squared. If they give you a window, always take it. In this case, they say 0 to 3. So change your window to 0 to 3. And then you should be goodish. You follow? Is everybody there? Give you one more minute. Okay, before we get into the questions, let's talk big idea conceptually here. This is the velocity graph. Okay, I'm going to call these points A, B, C, D, E, and 3. All right, so from time 0 to time A, what's going on movement-wise, assuming it's moving horizontally along the line? It is moving, okay, forward. All right, I was thinking right, left. What about right, left? Right, it's moving right. All right, now first of all, don't give me that physics stuff, okay? Depends on how you define your axes. Who do you think you are, okay? The right is positive, the up is positive, and that's all there is to it. You guys doesn't depend on nothing. It is what it is. Nobody, come on. All right, so it's moving right, and it is how in terms of its speed or velocity, is it moving faster or slower as we go? Faster, okay, cool. From A to B then, is it now moving left? Why not? Velocity is still positive, okay. So what is going on down with that down slope? What's happening? It's slowing down. At time B, velocity is 0, and therefore the particle is not moving or momentarily at rest, yeah? Does velocity equal 0 imply changing direction? What implies changing direction? Changing signs. Okay, cool. From B to C, what is going on in terms of particle movement? Moving left and faster, or slower and slower? Faster and faster. From time C to time D, it's moving left and slower. Time D, it's at rest. Time D to E, right, faster, and E to 3, right, slower. Okay, so what are the two candidates for farthest right? Time B, because that's the end of a rightward movement, and time 3, because that's the end of a rightward movement. What are the candidates for, or candidate for leftmost point? 0. Why is 0 a leftmost candidate? Because afterwards it moved right, so that might be a leftmost candidate. And what else? D. At time D, is it more right of where it started or more left, or what would you need to know? Area. Say I told you this area was greater than that area, then what would that imply? At time D, it was right of where it was at time 0. Yay? Okay, sounds good. All right. Let me clear the sink off. Let's go to the questions then. This is way beyond what one AP question would have, but this is bits and pieces that are common to AP questions. First of all, I don't know if you guys talked about speed, but they are very picky about how you justify speed. Okay, so find the acceleration of the particle at time 2. Then I'll talk about the speed. Acceleration of the particle at time 2. Now this is calculator active, so do I need to take the derivative of this by hand? No. Can I just report a number? No. Okay, you cannot just say, hey, that's calculator active, so here's the number, you figure out right. No. Even if it's calculator active, you still have to communicate what did you have the calculator do. So what did you have the calculator do? Take the derivative. So we want to communicate, hey, person reading this, V, A at T is the derivative of V at 2. It is understood and implied that you do not have to do that derivative by hand. It's calculator active, so you may use your calculator. And if you find the derivative at 2 by calculator, you get something along the lines of -8.6005. Tomorrow on the test, I will grade in accordance to the AP standards. How many decimals must you give? 3. Can you give more than 3? You surely can give more than 3. Does it have to be 3 rounded or 3 truncated or either one? Either one. So could you give -8.600 as an answer? Yes, that's truncating, it's fine. -8.60001, is that acceptable?
Yes.
Yes. Can you give -8.6005? Yes, you can give more. You cannot give less. Okay, so, -8.6005. I will almost always,
How many different
yeah, sorry, my bad. That was part of the one. So I did menu, maybe. I think I did. I calculate, my computer's all slow. So I did menu, calculus, so 4. Derivative is 1. And here's where I put the value. That's where you put your 2. Or whatever your value. Oops. Okay. And then the function, man, this thing is really slow. Function is F1. I only have one thing. Does that, you're good? Okay, my phone's like, here's, okay. Now, is the speed increasing or decreasing at time 2? Well, acceleration is negative, so speed is decreasing, right? Wrong. Is this true? Acceleration is negative, so velocity is decreasing. True? True. Speed increasing? Different. Speed increasing, decreasing is different. Imagine, I'm kind of worried about lawsuits nowadays, but imagine if I had a student up here that wouldn't sue me, and they were moving right. Okay? Now, if they're moving right, their velocity is positive. Now, I'm the accelerator. I go behind them, and I push them right. If their velocity was positive and I accelerated them positive, when they speed up or slow down? Speed up, okay? Now, say they were moving right, but I kind of just gave them a little, kind of got in their way, so that I pushed them a little that way. Would they speed up or slow down? Slow down. So it seems like when the acceleration is positive and velocity is positive, speed increased. And when acceleration is negative and velocity is positive, speed decreased, yeah? What if they were moving left and I pushed them left? Would they speed up or slow down? Speed up. So if they were both positive or both negative, speed increase. But if they're moving left, but I kind of slowed them down right, then speed would decrease. So on the AP Calculus test, they're a little picky about the wording. You need to say it's something like speed is increasing if. When do the cases where speed? Where are the cases where speed is increasing? Velocity and acceleration have the same sign. And speed is decreasing if velocity and acceleration have opposite signs. Okay? So to answer this question, it says, is the speed increasing or decreasing at time 2? Well, it's all about the velocity and the acceleration. So I need more. What else do I need to find? Yeah, I need v at 2 also to see, was it moving right or left, and then was it accelerated right or left? So v at 2 is just evaluating the function at 2. I got -2.270, yeah? -2.270. So it was moving left and accelerated left. So did it speed up or slow down? Yeah, we would say speed is increasing at time 2 because B and A have same sign. Okay, at that instant. Does that make sense? Okay. Um, graphically, this, just so we're clear, is this problem. Graphically, and graphs are never justification. My scale doesn't even have two showing. Ay, ay, ay. They didn't know how to do this. How do you change the scale so it'll show the scale? Go to Window, Settings, and say instead of X Scale Auto, just say I want it to show ones. Okay, now choose right here, yeah? Are you with me? Now this is the velocity graph. What would the speed graph look like? What would the speed graph look like? How does speed relate to velocity? Speed is the absolute value of velocity. So wouldn't the speed graph look like this? So at time 2, does it make sense that speed is increasing? Yeah, so it's all logical. Okay, now that said, that would never hold water on the AP test. You can't say, hey, it's because of this. Look at my graph. Graph is never justification. It's just for your own benefit to keep things clear in your head, okay? All right, going on to question B. By the way, I've made a few changes to my sheet, your notes, and I don't know if my slides always reflect it. So if I'm doing something that doesn't match what you have on your paper, please tell me, okay? I can't remember what they told me last class. B, does this match what you have? Okay, find all the times in the open interval where the particle changes direction, justify your answer. What are you going to do that? What are you going to do with your calculators? Find the zeros and then verify the change of direction. Now, on the AP test, or any test really, typical is you first read through all the questions first, so you know, oh, I'm going to need to store that, because I can see in part E I'm going to need that. So if you read through all this, you would know that you will need those stored. So when you find those zeros, can you please store them? Thank you. Okay, so find the zeros and store them. Let's call them A for the first and B for the second. Oh, darn it. This thing is so wonky. You have 1.7724 for the first one. Yes? I stored the first one to A, the second one to B. 2.506 for the second one. Are we cool? Okay, so the particle changes direction. At time equal 1.772, is that right? Is that, I can't remember what it said. Yeah. And the other one was time equal 2.507. Thank you. Would it be okay to say because velocity is 0 then? No, that does not satisfy the condition because velocity changes sign. Okay, cool. Total distance traveled by the particle from 0 to 3. I'm really having no issues here. Distance versus displacement. When you integrate V, then that's right, left, sign allowed. So let me just remind you of the big idea. Say I was here and I moved right 3 and left 3. What's my displacement? 0. What's my distance? Okay. Now, I would get a net displacement by allowing for the negative movement. So I would, if I want displacement, I want the sign to be there. And so, in this case, when you allow velocity to have its positives, its negatives, that gives you displacement, oui? But if you say, I don't care if it's right, I don't care if it's left, I just want to know how far did you go, well then instead of integrating velocity, you're integrating speed. When you integrate speed, you remove the sign and you're just finding, that's absolute value v, by the way, and you're finding distance. The once in a while, once every 5 years or so, they throw this little doozy point on there, and they're very picky about it. What about in cases where the velocity is positive? Then this is it still displacing? Yes. But if velocity is positive, say I'm here and I move 3, then isn't that 3 both the displacement and the distance? Okay. So if it's a case that velocity is positive, then that makes sense. Velocity and absolute value, wouldn't they be the same if velocity was positive anyway? Wouldn't those be exactly the same? So velocity is the integral is displacement and distance, and you must say so in those cases. Say so required. Okay, so let me give you a little, let's see, a little practice. Find the total distance traveled by the particle from 0 to 3. So if I want total distance from 0 to 3, does that mean integrate velocity or absolute value of velocity? Absolute value of velocity. Okay. So, we haven't talked about this. Jeez. How do you get integrals? I'm just curious. How do you get integrals in your calculator? You what? You go this? Okay. So, keystrokes 1. So, did you know there's another one? Shift plus. Oh, shift. Shift plus. If you do shift plus, that also gets you an integral. And maybe a little less keystrokes. Okay. So 0 to 3. Where's the absolute value function located? It's in that little menu here, yeah. That time you actually do that. And the function, x, boom. Do you get 4.657? Okay. So, in other words, over the time interval, I traveled a total distance of 4.65 units. 4.657 units. First of all, always say what the calculus was that you did. Okay, person reading this, I integrated speed from time 0 to time 3, and that's how I got my answer of 4.6579 units, yeah? Okay, it says find the total distance, I did that. Now, would you find and interpret the integral from 0 to 2? Shift plus. Function, sorry I'm slow. X, X. Okay, did you get 1.6315? All right. It does say not to just find it, but also to interpret it. When they grade for your interpreting of an integral, which is a very common problem, guaranteed to be on an AP test and a big part of calculus, knowing what the heck you just found. They look for four things: what it is with units and when it is with units. So what is this? This is the 1.6315 is the displacement. What units? In units from, and now when it is with units. From time equals 0 seconds to time equal 2 seconds. Okay. Would it also be true to say this is the position at time 2? No, that is not the position at time 2. You would have to know where it started, wouldn't you? So that's absolutely not true. Do not say it's the position at time 2. Not true, not true. Okay. Would you find and interpret the second integral, which feels redundant, but it is different? Bless you. 0.540. Is this expression or this number is the what? Displacement. And because velocity is positive, also the distance traveled in units from time equals 0 seconds to time equal 1 second. If you just said displacement, would you get that 1 point out of 1? Nope. Okay. If it's the case velocity is positive, you need to understand the distance and displacement are one and the same. Okay, moving on. Boom. In this case, the function cannot be easily integrated. Not everything can be integrated. Not everything is integrable. I like to say the word integrable. Sound like your mom, integrable. All right. In this case, the function is not easily integrated, or it can actually be integrated. Write an expression involving an integral for the position at any time t. Would you do that for me quick, please? Find a position function. I called it p of t. You could call it whatever you want, s of t, x of t. Feels like it's right there, so y of t would be done. Okay, so give me a function in terms of an integral. Is it just the integral or is there more? There's more. To get the position at time, you'd have to know the starting position plus the change in position. What's the starting position? P at 0. Plus the integral from 0 to t of v or absolute value of v? V. I need to know its displacement or change in position, not its distance. Change in position, except I wouldn't use t again. I would have to use something else, x or u, whatever you want, not v, obviously. Anything kind of dummy variable that's not already being used somewhere else. Do you think? Okay, cool. During the time interval 0 to 3, what's the greatest distance between the particle and the origin? The greatest distance between the particle and the origin. What do you read this as? What kind of question is this? Absolute extrema, okay. Absolute max or min? Max. Absolute max of p? Which is further from the origin? Negative 8 or positive 3? Negative 8. So I don't want the absolute max p, I want the absolute max of p without respect to sign. So I want the absolute max of the absolute value of P. Now, don't worry, I don't need to take my derivative on the absolute value of P. I'm just saying that when I get all the candidates, I'm going to blow off the sign and say which one numerically has the greatest value, right? Without respect to sign. You with me? Okay, so absolute max happens where? At endpoints or critical points. The endpoints surely are time 0 and time 3. How will you find the critical points here? Critical points will be where? V of t equals 0 or undefined, but I don't think there are any undefined cases for this problem. Do you agree? Okay. I can find those with my calculator. I think we already have them from earlier, 1.772 or something like that. Is that right? And what is the other one? 2.507. Okay. If a person just said, hey, my critical numbers are these, without saying what you did to find them, would that be satisfactory? You must say what you did. Okay? All right, cool. Now, I need to actually find position at each candidate, yeah? Do I need to communicate, hey, P at 3 is P at 0 plus, do I need to show all that? Depends on the problem. If in the any previous part of the problem, if you've communicated, hey, this is how I'm finding position, then you're good to go, you're covered. Now, in the previous parts, have you showed this is how you find position? Yeah, in this, I hate you. Isn't that this right here? Didn't I communicate how you find position anytime here? So if you've already communicated, this is how I find position, then you don't need to show all the work again. You can just report it. Now, if you haven't communicated, then you need to say, hey, this is my position function, or this is how I'm finding every one of these. Either way. Okay, but I have communicated how I'm doing this. P at 0 is -1, I believe that was given. I'm going to go right to left. P at 1.772, which I have stored as A, I believe. Okay, -1 plus, shucks. -1 plus, shift plus 0 to 1. Oh no, I have that as A, you dummy. Okay, what did you get for 1.772 or A? Did you get 0.8948? Okay, cool. Does that match the picture that went from -1 to 0.8948? Yeah, remember the graph said we were moving right in that time frame, so that seems logical. 8948. Okay, then find at the next candidate 2.507, which I call B. -0.569 or 560 if you like, depending on if you run or truncate. And P at 3. .729, yes? Okay, cool, 0.729. Now we're ready to make our conclusion. At what is the maximum distance between the particle and the origin? 1. The max distance is 1 unit. If you want to parenthetically say at time 0, that's fine. It's not required. They did ask for the distance, not the time at which it occurs. If this part, that to me is enough to get AP credit. If you wanted to really go above and beyond, you could say because the absolute value of negative 0.569 is less than the absolute value of 0.729, which is less than the absolute value of 0.8948, which is less than the absolute value of -1. That's good. It's not required, but it is good calculus. All right. I know this question isn't on your notes, but it's once in a while an AP question. Write an equation that would solve for the time when this particle is at the origin. What kind of equation could you give me to find when the particle is at the origin? At the origin implies what? Displacement is 0 or position is 0? Position is 0. So do we have a position equation? Yeah, couldn't you just say 0 equals -1 plus the integral from 0 to t of b, something like that? It doesn't say to solve it. It just says write an equation. Okay, and that would be a huge time interrupt on the test. You said, oh, yeah, now I got to find it. No, you don't have to find it. Read the question. It says just set up an equation. That's it. You with me? I believe this next part is different from my slides than it is for you. Is this, I think yours says something more like at time 2 or something like that, yeah? At time 2, away 6?
2.6.
2.6, okay, sorry. At time equal 2.6, is the particle moving toward or away from the origin? Okay, so how would you go about answering this? Would you just find the velocity at 2.6? And call it good. Would you find the velocity at 2.6, please? You don't have to communicate what you're doing there. They gave you the velocity, so you're just plugging into the function they give you. So you get 1.652. Okay? So the fact that that's positive, does that mean it's moving away from the origin? No, what else do we need? Now, where it is at 2.6. So now find the position at 2.6. Negative 0.492. All right. So where is it? How is it moving? With respect to the origin, it is left of the origin, moving towards the origin. So we conclude it's moving, particle is moving toward the origin. Why? Because, was it the numbers or the signs that told you? Signs. Bring reference to the sign. Because the particle is, the position is negative and the velocity is positive. Okay. And we're not going to get through all of J, but just looking at this. Freaking it. All right. Looking at this data here, right here. Ah, shoot. Whatever. We'll talk about it. It was a really good last question. All right. So I know we didn't get the questions, but 77 is due today. So if you have questions, come in 7:30 or after school and ask them. 77 is due today. Have a lovely day.